I'd like to welcome you to this video. We're going to go through some of the new functionality in version 3.405 of TIPS. One of the things you'll notice about is we've dropped the J prefix on JTIPS and everything's back to the original name of TIPS. This is the newest version of the well log modeler. The previous version, the major incorporation of technology was the ability to tie your well to the seismic data directly within TIPS. We obviously still have that and have added onto that capability. So I'm going to go through real quickly, some of the major interesting pieces of functionality we've added. The more detailed ones are included in the help documentation. If you have the software, you'll be able to see it right away. As a reminder, always look to go to help topics and video, and what will pop up will be a web browser that has all of the information as shown here, and you can look at this in the release notes, and you can look at the table of contents and all the reference, all the information. So don't forget that the help doc is always available. You can also search for our videos directly in that area as well. One of the things that we've added, it's always been a bit of an annoyance, and mainly it's because we started out the software focusing everything on AVO, and then we started adding more functionality related to 1D synthetics. And one of the legacy annoyances that we heard from users is that you had to create all of the same curves that you need for an AVO model and fluid substitution AVO model just to do a 1D synthetic. So I have an example in front of you where there's a well log, and then we pulled in a sonic curve, defined a P wave curve, and then we also have a bulk density curve. In the past, if you wanted to go create a 1D synthetic, you would have to go create a shear wave curve, or maybe even a shale volume curve. We've taken that out, so now I can go to, at this point, synthetics, and all I've defined is a P wave and a bulk density. And I can go to 1D models, and up pops our window of the 1D models using just that P wave and the density curve. Just a reminder, in the 1D models, you take this and you can apply a wavelet right there and generate that model. If I want to add another model, I go to Tools, Add Models, and I could put a different wavelet on it. I'll put a trapezoidal wavelet on it instead, and you'll be able to see these side by side. And you can keep adding these models to your heart's content. I can also add a model that has computed internal multiples. So now I can see the impact that I may have of multiples. So you can add all of these to your heart's content, and you can export all of these in SegWy and or ASCII form. So you go to Output, write SegWy, write ASCII. So that's just a quick little thing that we've been able to do. Now I'm going to pull up a more robust file that we have here. And this one is that has some hydrocarbon zones and everything else identified, and has a bunch of other curves that we have here. One of the things that people have asked about is there a way to understand exactly how we went from an LAS file to the current file. How did we create all this? It's kind of a storing the legacy information. So we can go to Tools, Create View Log Prep Summary, and this will also create an HTML document that'll show up in your well, and in your web browser. And you can see that I've got the source file, working file, and data curves, and it tells you for every curve where you had missing data, how you created, what its source were, bulk density. I can see all the areas where I've edited that information. Here's where my hydrocarbons are, custom lithologies if I had that, deviation or check shot. All that information would be in there. And that's just a nice little report. So if you ever want to be able to regenerate it or understand how you created that file, a couple years from now, that report's always there. And you can, every time you make a change, it updates whenever you go to produce it. So you can save that for you in the future. It's kind of a handy tool. One of the other things that we've done, when you go to edit a curve, like let's say I'm going to edit my bulk density, and I can right mouse on that node and say edit the bulk density curve data, and this pops up. I'm just going to zoom into some arbitrary region, and let's say I was missing data in here, and I want to add the data. I put it in the editing region. This is all basic functionality. One of the messes we always have is to calculate. And you calculate, generally speaking, with density using the Gardner type equation and using the constants that are in the system for anhydrite, dolomite, so on and so forth. It estimates what that density would be off of the shale volume and the P-wave curve. Now let's say I want to create my own regression coefficients for a Gardner type equation. We now have a tool. When you go to curves in the top menu, you click on the node. So I want to create one for bulk density. Forget the standard Gardner ones. I want to use what's in this well. And so I'm going to go to compute regression coefficients. All right, so what I'm going to do, and it tells me right at the top, compute your Gardner type relationships for bulk density. And it's going to use this formula right here, where bulk density is equal to a value A times whatever parameter X is and a value B. So what's parameter X? It's our independent variable. In this case, it would say P-wave, but we can really make it anything we want. Let's just go ahead and make it sonic so we don't have to worry about the P-wave. Then right off the bat, you'll see it pops in this range right here, this window, and it puts the sonic data here, and it's going to try to compute these regression coefficients that would fit into this equation. Now right now, I also get this message. It says bulk density contains missing data in this depth range. So we've got data over here because we've got a really broad range that's missing on the bulk density. So we can't estimate it if we have data missing in that area. So I'm going to just focus on this area in between these hydrocarbon zones. And I'll zoom in a little bit here so we can see. Okay, and I'll hit the compute button just so that we can see it update. And it tells me that my coefficient A is 3.824, B is negative 0.106, and a correlation coefficient of 47%. So again, I'm using the sonic data, and the yellow curve that you can see on the bulk density is what would be predicted based on that sonic curve. Now it's up to you to determine if that's acceptable or not. But what you're doing is using defined well data to come up with a good correlation that you can then use on any other well. So as I move this curve, this range, and I just want to compute over this range, this updates. Then I can save this, and I'm going to call it, the default name gives you the name of the well, what the independent parameters and the depth range, and I can just save that. And then when I go to any other well, and I need to estimate density, I can use that correlation that I just computed. So regardless, and it's a good tool to have if you have a really good log data in a certain area, but you've got a nearby well that has some bad density data, for instance. You could create this relationship, which would be fairly representative of what you're trying to do in that area, and apply it right away. Another little quick thing that we've added, when you go to the synthetics, and I'll go to our AVO model, we've always had this. So this is your well log curve, as you know, and the AVO synthetic shown on the right-hand side. So we show the synthetic, we show the stack curves. We have the option to show them, and we can show any number that we want, as well as the intercept and gradients. And by default, you can specify what that when you compute the stack, really what the far angle was, 50 degrees in this case. So right now this stack is from 0 to 50 degrees. We've made a minor update to that, which seems insignificant, but when I come over to here and I click on the properties for the synthetic controls, and then I hit stack and AVO inversion, I now have a min stack angle and a max stack angle. So I could go from 30 degrees to 50 degrees. So right here we're at 0 to 50. Okay, now I'm at 30 to 50. So I'm looking at the far offsets and all that. Again, fairly simple little update, but I know it's something that people have asked about. I'm going to pull up a file that's got some seismic data in it. I'm going to show you a few of the things in the seismic toolbar. So again, when we have a well log, we want to go tie it to seismic data. We click on seismic and open seismic, and we pull in a 2D line. We're not pulling in 3D volumes at this point. If you try to pull in something with more than several thousand traces, it'll pop up and tell you it's too big, in which case you'll need to use some other tool to extract a reasonable line. Again, we're trying to do well ties here. So what's shown in here, here's your seismic data. The well log that you put in here, this is the 1D synthetic. It's come down here. We've got some flags at the bottom. This is telling me this is primaries plus multiples. Again, this is functionality that was there before. But I'm also added in a cross correlation. So between 1.5 and 2.1 seconds, this is my cross correlation. And my root mean square of the synthetic is 0.022. And my root mean square for the traces of the seismic data from there is much greater. So you can see those little bit, some informative data. To control this, you would go to Tools, Cross Correlation Settings, and you'll pop up, top time, bottom time. If you don't want to see that down there, just uncheck that button and boom, you don't see that. Similarly, Tool, RMS Settings, if I don't want to see that, I don't see that. And there you give me the time range as well as the left and right trace index of the seismic data to compute. So now I have that information. Other little things we could do, it's the headers in the past. We just had some indices that we would show, but now if you click on this, when you hold your mouse over this, it'll tell you to click on this to pop up, or you can go to View, Set Seismic Display Properties. I find it much easier and intuitive to click on there. And then I've got my traces branch, but I have this new one, this trace header fields. So this is all the stuff that I want to show up in here. And this is going to vary, obviously, from SegWi file to SegWi file. And if I click on these three little dots here, I'm going to get a menu that pops up. These are all of the available attributes, and these are the selected ones. So if I want to show, if I scroll down to, CDPY and there, or inline number or crossline number. Okay, so I double clicked on those, or you could click on any one of these values these are the standard SegWi parameters, and I can click on this arrow right button. Similarly, to remove one, I can click on the arrow left, or I double click on this side. Once on this side, I can move these up and down if I want to get the right order. Now, one of the things that we're always going to show no matter what is the trace number. And let me get this over just because I know this will show decent. So these are the three attributes that I now want to hit select, and I hit accept and close that again. And so I picked three, but there's always four. So we always give you the trace number down here. That goes from 1 to the number of traces in your seismic file. And so that's just because we don't always know what's there. And plus, when we want to go look at inserting our well, we need to know where we're going to put that in. So that's a little thing that we've got there. One of the things that's kind of cool to do, so when we put in the synthetic, we're showing this as a 1D synthetic. This is your near trace. Now let's say my seismic data was far offsets. How would the far offsets of the synthetic compare? Well, what we can do now is we go to well, and there's a button down here that says Edit Synthetic Offset. So I have an option right here that says Use AVO Stack Traces, and my initial stack offset and final, and then an increment. Okay, now the model has to be capable of having enough information specified to create an AVO model. So it has to have, and if it's not, it's just going to pop up and tell you can't do that. So I'm going to say Use AVO Stack Traces, and I'll go from initial stack trace from 600, let's do 1,200 feet to 1,800 feet, and I'll run a stack at every 50 feet. So now it's going to go, it just computed the AVO. So this is the far, and it tells me at the bottom, this is my stack from 1,200 to 1,800. And so now what I'm doing is a quick comparison of the seismic data with the far offsets of the well log. You've got to be careful when you do that if all your seismic data is near offsets and everything else, but it's a really nice tool to allow you to investigate what may be going on. If I want to get back to just doing the near synthetic, I go to Edit Well, Edit Synthetic Offset, and I unclick the Use AVO Stack Traces. And there we go. One other quick thing you can do, you can always go, something that's new is the ability to output the formation tops. So you can write the formation tops. When you do that, that'll output the formation tops in depth as well as their two-way travel time. And you can export the synthetic and the SegWide form as well as ASCII form to use that in your other tools. That's a quick overview of some of the new stuff. We've got a lot of other great functionality in develop looking to come out. Always looking to hear more feedback from the users. So if you have questions, always come back to us, and we hope you'll enjoy using this new version of TIPS.